Okay, let's look at this practice question from Lab 7. Okay? The practice question is going to ask us to do 3 things in this first part. Calculate the individual dilution factor, the overall dilution factor, and the CFUs per mil of a single individual plate, which we'll get to in a second. So we're going to need 3 equations to be able to go through these 3 steps here. Okay? So the first is the equation for individual dilution factors. Okay? And that is the amount added over the total volume. Okay? And dilutions are unitless because amount added is in milliliters, total volume is in milliliters, and therefore the dilution is unitless. Okay? So for example, over here, from our original, which is 0, tube 0 in our procedure, we added 0.1 mLs into the tube that had 9.9 mLs of sterile water. So that individual dilution factor is going to be 0.1 divided by 10, or 0.1 over 10, which is the same as 1 over 100. And we'll get through that in a second. Okay? The next equation that we're going to need is the overall dilution factor. So yes, for example, this tube here, we've diluted it out 1 over 100 times, or 10 to the negative 2. Then when we use that liquid to then make our second dilution in B, then this liquid is already dilute. So the aggregate of the dilutions needs to be represented in the overall dilution factor. So what we're going to do is multiply the overall dilution factor from the previous tube by the new individual dilution factor. Okay? So if we're looking at B, our overall dilution factor from A, we said was 1 over 100. And then we put 0.1 over 10, again 1 over 100 in B. So we multiply out the overall dilution factor from A multiplied by the overall dilution factor from, or the individual, dilution factor from B, and that gives us 1 over 10,000. And you'll see that in a second when I go through all those numbers, or 10 to the negative 4. Okay, and then the last equation that we need is CFU per mil. CFU per mil, once we've gone through the dilutions and we've plated our organisms and we've counted them and we've chosen the plate that's between 30 and 300, we can use this equation here to then extrapolate what was the original bacterial load in the original sample. Okay, so we get number of colonies here. And these are from the plates that have countable colonies between 30 and 300, right? We're going to choose the plate that has the appropriate number of countable colonies. And we divide that by the overall dilution factor of the tube that we got this solution from, multiplied by the amount plated. And we said that's really important because sometimes equations will have an assumption about the amount plated, but if it's anything less than 1, it actually changes the math, and it changes an order of magnitude. So we should include it in our calculations. So we said previously that dilutions are unitless, okay, because you have milliliters over milliliters throughout the equation that cancel out. But our bacterial load is in the units, colony forming units per mil, and that's because number of colonies, the units there is CFU, and then the amount plated, the units there is milliliters. Our dilution factor, we said that's unitless, and so we get CFUs per mil for this equation here. Okay? So these three equations will help us solve this problem here. So let's go ahead and start at the top. First, we're asked for the individual dilution factors. So just note that in this particular example, the flask is the equivalent of R0 in our procedure, which is the undiluted bacterial slurry that we've made, okay? And then A is our first dilution, so equivalent to tube number 1 in our particular procedure, okay? So let's look at A first. Like we said, we added 0.1 mLs, and then the total volume, once we've added the 0.1 mLs, becomes 10. So 0.1 mLs is the amount added. The total volume is 10, and so that is 10 to the negative 2, or a 1/100th dilution, right? 1/100th, because if we move this decimal over, that becomes 1. We move this decimal over, that becomes 100, okay? So a 10 to the negative 2 dilution for the individual dilution factor for A, okay? Now, let's look at 2B. Individual dilution factor for 2B is the same, 0.1 mLs, and then the total volume after we add the 0.1 mLs is 10. So 0.1 mLs over 10 mLs, that's going to be another 10 to the negative 2. Okay? So both A and B are both 1/100th dilutions. Okay? Now C, we've changed it here. And like we said, in a procedure in the lab, we usually wouldn't change the aliquots or the individual dilution factors. We wouldn't change the aliquots that we were transferring over the serial dilution generally, with some exceptions. But for the purpose of practicing the math here, we have these different individual dilution factors for these different tubes, okay? So C, we've transferred 1 ml, and then once we've transferred it in, we get a total of 10 mLs. Okay, so this is similar to what we did in lab for a 10 to the negative 1 dilution for tube C for the individual dilution factor. Okay? Now, tube D has a 0.5 ml going into 4.5 mLs, so that's 0.5 mLs over 5. If you're to do this math, then you will see that this is the same actually as 1 over 10. See? The half multiplied by 2 would be a 1, 5 multiplied by 2 would be a 10, so that's going to be the same as a 10 to the negative 1 dilution. Or you could just divide the 0.5 by the 5. You'll see that that's a 10 to the negative 1 dilution, okay? So tubes A and B are 10 to the negative 2 dilutions. Tubes C and D are 10 to the negative 1 dilutions. And then we do something really funny here in tube E, where we transfer over 1 ml of liquid into 1 ml of liquid for a total of 2. So this is a 0.5 dilution, okay? Okay, and that gives us our individual dilution factors for all of our tubes, okay? And it doesn't matter how you annotate these. You can write it in scientific notation, or you can write it as a decimal or a fraction, but A is a 10 to the negative 2 dilution for the individual dilution factor. B is a 10 to the negative 2 dilusion, C is a 10 to the negative 1 dilusion, D 10 to the negative 1 dilusion, and E is a 0.5 dilution. Now, that's just each tube standalone, right? That's the individual dilution factors. But since we continue within a series to dilute these tubes, we need to know what the overall dilution factors are, because even though C and D are both 10 to the negative 1 dilution, because you've diluted the previous aliquot, you would need to see what's the overall or final or overall dilution factor for D, which is going to be different from C, right? Because you're continuously diluting this liquid over the series, okay? And so we'll do this second equation here for the overall dilution factor, where we take the previous overall dilution factor and multiply it by the new individual dilution factor. So for A, well, what's the previous dilution factor? Remember that 0 has a dilution factor of 1 over 1, okay? And so that's our original culture or original slurry of bacteria. And so we would just multiply the 1 by the 10 to the negative 2. And so A's overall dilution factor is the same as A's individual dilution factor. Okay? Then for B, the individual tube was diluted 100 times, but it was diluted with a liquid that was already 100 times dilute. So we multiply the 10 to the negative 2 by the 10 to the negative 2, and we get 10 to the negative 4. Okay? And so even though the individual dilution factor was the same, since the liquid we used was already dilute, the overall dilution is much more in B than it is in A. Okay? We'll do the same for C. We'll take the 10 to the negative 4, which is the overall dilution factor for the tube that we got the liquid from. We added that liquid to C using an individual dilution factor of 10 to the negative 1, so that gives us 10 to the negative 5. Okay? So our overall dilution factor is 10 to the negative 5, even though our individual dilution factor is 10 to the negative 1. Okay? Now, for D, we used a liquid, so here's D, we used a liquid that was already 10 to the negative 5 times dilute, and we diluted it again 1 order of magnitude. So we multiply the 10 to the negative 5 by the 10 to the negative 1, and we get 10 to the negative 6. Okay? And we'll do the same thing for this last step here. 10 to the negative 6 multiplied by 0.5. You can use a calculator to plug and chug, or you can just move your decimals over and say that this is 5 times 10 to the negative 7. Okay? And so in that way, you've used your first two equations, the individual dilution factor, to figure out what your individual dilution factor is for each tube. Then you've used the equation for the overall dilution factor to figure out the overall dilution for each tube as you continue to dilute the liquid in the serial dilution. And then, just like we did in class, we take the liquid from each one of these tubes and plate a certain amount on the plate, use the hockey stick to spread it, and then incubate that. After 2 days, we come back and we see the growth on the plate. Now for these earlier tubes, oftentimes we have too many to count or a bacterial lawn. But usually, once you get dilute enough, you start to have countable colonies, okay? So one thing I really want you to pay attention to is the amount that's plated in this particular example is sometimes different from the amount that we plated in class. In class, we plated 0.1 mLs, but for the example that we're about to do the math for, they plated just 1 single ml, okay? And so we're gonna be able to deal with that by plugging it into our equation, but I don't want you to miss that their amount plated is different from the amount that we plated in our class, okay? So I'm running out of space on the board here, so I'm just gonna do this question right here on the side, okay? And so the question says, if plate F has 134 colonies, what is the CFU per mil of the original sample in the flask? So here's plate F. It has 134 colonies. That is between the 30 and 300, so we can use that, okay? And so we're gonna plug the information that we have so far, plus the 134 colonies, into this equation here that gives us the CFUs per mil in the original solution, okay? So CFUs per mil, we take the number of colonies. For F, that's 134 CFU, colony forming units, okay? Now we need the overall dilution factor for the liquid from the tube that we took our aliquot from. And in this case, F, if you see this arrow here, is coming from tube D. So I need to come down here and get the overall dilution factor from tube D. Okay, so that's 10 to the negative 6. And then I need the amount plated in milliliters. So that's what we said here is the 1 ml, which is different from how our procedure was, but it's also one way to do the procedure, is 1 ml. And you see when we use 1 ml, multiplied by the 10 to the negative 6, it doesn't change the dilution. Whereas when we use 0.1 ml, it changes the dilution. It acts like another dilution essentially, okay? And so if you plug in chug, you should get 134 million CFUs per mil, or you can write that in scientific notation as 1.34 times 10 to the 8 CFUs per mil. Okay? And so the number or the bacterial load that was in this original flask is therefore 1.34 times 10 to the 8th, or 134 million colony forming units per milliliter of this solution here. Okay? And so in that way, we're able to take a solution with an unknown bacterial load, dilute it out and plate it, and then extrapolate what was the bacterial load within that slurry, within that original slurry that we made. Okay? So hopefully that'll help with that first practice question for Lab 7, and feel free to email me if you have any questions.